and welcome to the VEST webinar series. I'm John Forster, your moderator for today's webinar session. And today we'll be showcasing some exciting new enhancements available in the MDTools 985 beta. Though not sure if this is your first webinar, but this webinar is expected to last for 30 minutes, and you'll be able to submit questions or comments at any time during the webinar. Just post it in the questions section located within your webinar control panel. And questions may be answered as they are posted, or we'll try to address them in the last 5 minutes or so of the webinar. So just a reminder, today's webinar session is being recorded and that the audio is muted for all attendees. So if you do have any questions or experience any technical issues, please alert us in the chat window and our support staff will follow up. So now it's my pleasure to introduce our speaker for today's webinar session, Carlo Molon. Carlo has worked in the hydraulics industry for many years and currently manages application sales and training for VEST desktop and cloud products. So Carlo, we'll turn it over to you. Thanks.
Thank you, John, for the introduction, and thank you all attendees for participating to this webinar. So today we'll talk about 985 beta version. If you're interested in testing the beta in your design workflow, we will be pleased to share. So at the end of the webinar, you will get instructions if you want. As always, a new version for MDTools will have some improvements for design environment, assembly, and generic, maybe more hidden enhancement. We go through more or less each of them. Here we can see a picture taken from the What's New PDF that you get together with the beta version. But I'd like, instead of going through each of them, I'd like to show you a design workflow, and I highlighted a new feature during a design workflow, which I believe will make sense also to consolidate and showcase how MDTools is used to design a hydraulic manifold. So since one of the improvement is related to engravings starting from HydroCAD diagram, I have already prepared a HydroCAD diagram of a small manifold. So it's nothing so complicated. I have a slip-in element because there are some improvement in the way assembly are made with the slip-in valves. There is a footprint. I decided to create a manifold mounted to a cylinder in order to show a new feature regarding mirroring footprint, adding O-ring grooves. And also the new announcement for hydro is related to the engraving position. So let me quickly create networks. I already have done that before this demo, this webinar. So this is just a command in Hydro where we can identify the networks for the block. And I want to export my manifold to MDTools. And now we will start our journey with MDTools 985. I can export the XML and save into my manifold XML. So now I forget the diagram and I go inside the SolidWorks. I'm using 23. We have compatibility with older and newer version, SolidWorks 24. As of now, we don't have full compatibility with 25 SolidWorks. It has been released at the end of last year. So please hold off with upgrades if you plan to, because there are some bugs which we identified and they are acknowledged by the SOL. So we are waiting for a fix that should be coming in few months. But if you are interested in upgrading to SolidWorks 25, please let us know and we will inform when it's safe to do the upgrade. So now I'll start loading my schematic. And the schematic will load, and in case there are some doubts or something will be asked, but now nothing is wrong in my diagram. A hidden enhancement in 985 is that we improved the readability of the interface with a 4K display. This is applicable mainly with laptops with high dot per inch ratio. So you will see that there is a better readability. It's not visible during this webinar because normally I don't use a super full 4K screen when doing webinars for bandwidth. So let me start a block. And let me make, let's say 200 millimeter by 160 by 160, then we'll change accordingly. So like I was mentioning, one enhancement is related to the position for the engravings. So if I place a footprint now and I place my DO7 footprint, in the past, as of now, and this is applicable to Inventor as well, not only SolidWorks, the default position for engraving is within the boundaries. Basically, the engraving by default goes next to the parent cavity of the footprint. Now the boundary is, the engraving is outside. Still it's too close, so we are going to change a bit in the final release version, but as of now the engraving will be outside. So sometimes it happens that the user forget to change the position for the engraving, so now it's in a safer area. If you want to change the location of an engraving, remember it can be done from the MDTools ribbon. Just right click, edit, and then we can change the position. Maybe in this case I want a position of 40 millimeter, and okay. Or otherwise we can yes, locate the engravings with the engraving text command doing edit. Now a second enhancement is related to the possibility to mirror a footprint at insertion. This can be done with components from the library. As an example, this is a very common request we get. Where can I find a mirror DO5 footprint in order to make a sandwich mounted manifold? So now we have DO5 and the possibility to mirror footprint. Now this block has not the DO5. I show the command from the hydro schematic. So basically in the hydro schematic, I want to place my B1 flange. So this manifold is flanged to a cylinder through SAE 6000 3x4 flange. So this I will need a mirror flange, so I can insert my flange. Now, while inserting, since it's a mirror flange, I have the possibility to select the type of bolts. So I want a through bolt hole with counterbore, and this will go into the library. I have a special library of bolt holes. Well, I'm using currently my standard library for which I use in the production environment. In addition, it is possible to select the O-ring. So in this case, I want a groove, and by default, MDTools will show O-ring grooves compatible with this diameter. If you show all, it will read all the O-ring from your library. So in this case, normally it's used Parker 214 O-ring. So I'll take this one. And when I click OK, now MDTools is asking to place the footprint on the block. So we can see a preview with the true bolt holes. I can rotate my bolt hole. I'll try to position in the center. That was 180 millimeter, and let's leave as is now. When we click OK, now MDTools will place the flange with the opposite bolt holes and also with the engraving in a better position than earlier. Now let me save my block. With previous version of MDTools, the presence of engravings was slowing down quite a bit significantly the design. Now we have improved and changed the way the sketch are managed and also the way the non-cosmetic engravings are managed. We'll see in a minute, but that's a really interesting hidden new feature. So all the design workflow will be faster with this new version of MDTools. As always, we can design selecting cavities and connecting. And now let me place with reference to the other cavity at 0 on the Y. Let me change the reference. That is my position. And we can design by network. So let me go and take the tank network, which I want to position on this face and maybe slightly down here. And again, the position for the engraving will be outside the boundaries. I can stretch a drill. up to something else. I can create inclined drills as an example. Now, this may not be the best way to make this connection, but let's try. Maybe at 20 degrees will be okay. By default, automatically MDTools will reduce the diameter with the diameter that is compatible with the max diameter. This may be at risk. We can measure the wall thickness between, so we can measure the wall thickness between drills. That's 3.71. It's not a lot for a large diameter, but this is a tank line, so I think it's okay for this design purpose. Let me go and place the DIN pocket, which I want to position somewhere here. Well, maybe I move to a different location on this face. We also have a relief valve in the schematic, a DBD10 Bosch Rexroth. So let me insert it and let me place somewhere here. That may not be a perfect position. I need to connect the blue lines. So let me swap cavities. Swap cavities is an interesting, it's not a new command, but sometimes if you change the position of, if you find that two cavities are in the opposite position, you can use the swap command and this will simply change the position. I want to move slightly up my cavity here. And we can add material in between. Well, we can stretch the block according to what we want, 165. As you can see here, I have some overlapping. So let me move my logic element slightly below. This should be good. Now I want to create connection lines. Let's say that I want the pressure in the same phase as the tank. So I take the P port, insert here, and connect with the slip-in valve and doing a rotation, and the position looks okay. I want to connect the tank line, so I'll make a construction port from top. I just need a 3x8 PSP plug on the top face. Sometimes this is due to some SolidWorks zero thickness geometries. You may see that a cavity is disappearing. This may happen in feature mode. When that happens, just really slightly move or slightly change the diameter. In this case, I will change the diameter to let me edit. I'll change the diameter to a 13.95. That should be okay. It's a tangent with other surface. Sometimes SolidWorks is unable to handle zero thickness geometry, so that's a pretty common problem with SolidWorks in some geometry cases. I want to insert the plug. This may not be a good position, so let me change face and position here. That is okay. In this case, the plug is entering inside the cavity, so let me change the spot face. Let me put a 1 mm spot face. And I want to use the same plug to do the connection. 1x2 and position here and move it down. And this is going to make a connection. Maybe here I can have the same problem of zero thickness. In these cases, it's always some tangent position that should be solved just by moving this cavity by maybe some fraction of millimeter. So when you have zero thickness, in that case, the problem was tangent with this, with the end of the thread. When you don't see colors in a cavity, just edit and click OK, and this will refresh the color for that cavity. I want to put another plug here, and a 1x8 PSP plug on this face, and the position might be here. We have all the checking. Nothing has changed in terms of checking, design checks. So in this case, I will not run. We don't have enough time to run all the design check. In order to make this connection, I like to rotate the slip-in valve in order to get the blue line, so the pilot, the X channel going directly into the chamber. As you can see, in case of overlapping engravings, we may need to relocate them, so edit. When we want to relocate, we can use the arrow keys to change the position. A faster method is really to pick a new location. In case of slip-in valves coming from hydro, the engraving are grouped. If you want, you can put into 2 different rows according to your needs, and then you can click OK or change the position. Now the position is good, so let me leave them where they are. A1 is okay, 205 is okay, and the other engravings looks good. Normally, we don't put engravings on a surface that is finished to go into another component like the cylinder. So in this case, I will remove the B1 engraving. This block has also a drain line, which I want on the top face and connect in the center with a 8mm, 6mm diameter. Maybe any position will work. And in addition, I had put a shuttle valve for a load sense signal. So now let me find a spot here. So I will not spend much time in optimizing the block, but I'll just finish it. I'll take a 1x8 PSP plug on this face to do the connections. This is a sun valve. I can see that there is no open connection here for the brown channel, so I can sink the cavity. Maybe I'll change the locating shoulder to 30mm. And I'll also add the construction port here. And now I have the spot for the locating shoulder, which I can find directly here. So for the load sense signal, load sense here, and connect maybe with an 8mm diameter. We have the check against schematic, which is here. I see that I'm missing the MB1, so the test point for the B channel, which I have a easy spot here, MB1 here, connecting there with a 5mm diameter. I see a question. So it's a first user. He wants to see the assembly. So I'll come to the assembly shortly because it's part of today's webinar. So here we have been focusing on designing the block. So like I have mentioned, it is possible to do verification of the block. So let me quickly go through some design checks. I will do a connection check. So the connection check will tell me if I made all the proper connection in my block. So those are false warning. So it's just the bolt hole that are made on 2 opposite faces and they touch each other in the mid. So it's not, it's a false warning. Have you had some quality connection issues? Usually that is because of 2 short drills. And actually in this case, in fact, the drill is not long enough. We can optimize a bit the drill. Now I'll do manually, but we have a command that can optimize it automatically for us. So I'll just stretch my drill, 84mm. And now I have made a better connection. If I do again the connection check, now this will tell me that that issue is solved. This one is still an open issue, so I can. That quality check tells us if we made a connection that is good in terms of nominal area opened by the drills. So 83, that should be good. Usually we try to have as possible a round corner. So now this will be okay, and now there are no other issues. We have a broken network. B1. Ah, yes, of course. I forgot to connect this here. That was a good pick. I forgot really to connect the brown channel. So 6. Okay. And now we have the block. Another change as an improvement is on the speed for moving the engraving to cosmetic. I can see now the P is in a wrong position, so let me move it there and click OK. We have improved a lot the speed for turning the engravings to non-cosmetic, so we can quickly change to non-cosmetic. In the past, MDTools was using a function of SolidWorks called wrap text wrap. Now we use extrusion. We found it more efficient in terms of speed. So you will see a big improvement. As you can see, it's cut extrude for all but this will have an impact in design speed. As always, we can do wall thickness check. So in my case, I will do a 5 millimeter wall thickness check around all block. The only issue now is this 3.7 millimeter, which I had already studied. There is a clearance issue in the same network, which is not an issue. Usually, in fact, it's between the two parallel drills, the B and the plug. And there are other issues between the spot face. So in this case, it's 4 millimeter of minimum distance, but from what I can see, there is no problem in this design. So I can save my block. In order to show you a functionality in the machining drawing, I will run one command called machining ID. This command is in preparation of a drill chart, which recently I've been not be using too much during my webinar. So today I'll show you a bit of drill chart. With machining ID command, I'll be able to assign to each drills in the block a unique ID, which I'll be showing you shortly in the machining drawing. Practically, a cavity will have a component ID, which is the name of the component that is coming from the schematic, and a machining ID, in this case 208. For the machining ID rules I have in place, 200 is the phase 2, and 08 means that there are at least 8 features, different features in this phase, which is phase 2. I now going to the assembly environment, new assembly, and I'll place my webinar block here. I get back shortly to the schematic. So basically in the schematic in HydroCAD, I have linked 3D models in SolidWorks format. These 3D models have a constraint set in order to make the automatic assembly. So basically what I can do to make the assembly is just to auto assemble. When auto assemble, MDTools will load all the plugs and all the valves that are coming from the schematic. The plugs are not coming from the schematic, they come from the library, the MDTools library that I have used. So every time I insert a construction part, it knows that there is a plug to be placed in the assembly. When I click assemble, it will place all the components in one go. Comparing the speed for assembly with the older version, we have improved a lot. This improvement is also in the 980 version. In the past, it was much slower. At present, it's not possible to assemble O-ring in a flange. While technically it is on a single drill, but it's not technically doable. So if you need to assemble O-rings, you will need to use standard SolidWorks commands. As you can see, all the components have been placed automatically. A change that happened in this version is regarding the constraint rules, assembly rules for slip-in valves. I have already described it in a webinar in January. I'll briefly show you again. So practically, if I open the DIN pocket, this NG16 pocket, let me open. So that's the MDTools library, slip-in cartridge. This is the thin pocket. Practically, in order to make automatic assembly, MDTools was needing BH1 and BH2 as two axes to condition the assembly. And if the user wanted to insert the sleeping valve, basically it was needed to insert the cartridge. It was needed to create this fake axis, these axes that are not really present in the block. Now we change, so basically if we look at the mating made in SolidWorks, let me find the mating between the, yes, there we are. So we have the mating. So basically now MDTools is assembling just with one constraint type. If I open the block, this component, what we need in order to define the assembly rules are simply like a cartridge valve, a top plane, a bottom plane, and an axis. That's it. And then MDTools will take care about the assembly. In the past, it was needed to use the valve pattern, so we needed two axes in order to create the automatic assembly, which was not really handy. So now you are free to add assembly constraint as a cartridge valve using top face, bottom face, and axis, and MDTools will take care for the assembly. Nothing changed for the cover. So in case of the cover, which I'm now opening, LFA 16, in case of the cover, the constraint, the mating are two axes and two planes. Actually, in this case, this probably is an old model. I used the locating pin. So in older version of MDTools, we needed to use the locating pin. It's up to you. You can use the locating pin and BH1, but my recommendation, if you want to instruct component, always use BH1 and BH2, nothing else. Because if you use locating pin, it will be much more complicated in order to have a good precision for assembly. So that's a change in the assembly environment. Another change, which I'm not showing you, but I ended up finding in practical case, if you assemble another manifold to this manifold, like a sandwich plate, then when you run the assembly interface, MDTools will not show you the current manifold, but will show the other manifold you assemble. Now we handle this situation, so even if you add multiple manifolds in the SolidWorks browser, when you run the assembly interface, MDTools will list the primary manifold, in this case the webinar manifold. What I can do with this assembly interface is, as an example, I could link fittings if I had not linked directly into the schematic. So in this case, it's a 3x8 G10 SR, should be okay. And now I can assemble automatically some fittings to the ports. So drain port and load sense signal will go directly to something else in somewhere else in the plant. Now we go to the let me save the assembly. We go to the machining drawing, which has some good enhancement. So let me make a new drawing. And I'll create my views for the drawing, for the part. So now we have all the 6 views in the block. So for those doing a drill chart, we need the machining IDs. So there are 2 possibilities for showing machining ID. One is the following, which is the one I most commonly use. So basically, MDTools is attaching to each cavity the number that we have generated in the part file. To this number, there will be a corresponding line in the drill chart. Now, a change in the drill chart is that we are able to create a separate drill chart by phase. This is a really welcome enhancement because you can decide which drill chart, and it's pretty common to, in case of blocks with the decent complexity to split drill chart by phase. So in my case, I've just created a drill chart for phase 2. With the older version of MDTools, it was possible to create a split chart by phase only through the automatic machining drawing. But later in the manual machining drawing, it was not possible. Now you have this flexibility, which I like a lot, because if you do drill chart drawings, then this will help a lot. Also, we have an enhancement. Instead of displaying all the machining ID, well, actually in the past, it was not possible to hide them. You had to manually delete them. This was never really a big issue, except for the new user, which always end up in finding problems because they click and then they are unable to hide something. Now we have the possibility to hide this text automatically. So in any case, if you by mistake create a machine ID, you can remove them just with one command. Some customer prefer to show the machine ID through balloons. So when we use the balloon command, now MDTools is trying to pick a decent position for the balloons. Honestly, I don't use this technique. I have played a bit in the last days, and I have found I show you some issues. So we are going to fix in the release, but feel free to if you test the version. So in this development, we can see that there are some crossing balloons, which is not something that should happen. So we will try to look at the logic and improve the logic. Of course, it's easy also to then move the balloons. So it's important that MDTools does a decent job, and then the user can always do some slightly change in the position. But as far as crossing lines, I think it should never happen that two lines are crossing. So the logic can be improved in order at least to avoid crossing. Then the user can always quickly change the position. So I believe it's not a showstopper for a beta. And of course, we will try to see what we can do to improve this logic in the final version. Let me see the other changes that were in the. So in the drawing enhancement, we have seen the addition of show hide annotation, the balloons, and the machine drawing with phase titles. There is a hidden change in terms of construction plugs. Well, I've been using flanges as a construction plugs in industrial large manifolds, also in older version. So it was technically doable, but MDTools was not able to automatically assemble the flanges. Now it will support also automatic plugged flanges. Child manifolds, I mentioned, improvement to slip-in cartridge assembly, and the engravings outside the manifold footprint, which is really not an assembly enhancement, it's more a part drawing enhancement. In terms of functionalities, I mentioned the 4K display, the speed for engravings, mirror footprint we have seen, insert orifice on a port without step 12. I remember there was a specific customer using it. I'll show you quickly on a practical case. Let me go to the block. And so some customer do not always like the structure of the port being split into all these diameters. So I've seen in some libraries a situation where the customer has created, let me show you quickly how to replicate this situation. A BSP port, like a 3x8 BSP port, without a step 12. And of course, you will need to change also the nodes. That's not an MDTools training, so trust me, I'm doing quickly because we don't have too much time. So for me, that's no step 12. So basically, I've just the port without the step 12, which is normally the connection drill. And let me save as. So that's a new cavity I've made starting from another one. So this is a really special case. MDTools historically has was never developed managing cavities without a step 12, except for simple drills where there is only the step 0. So now we have improved because we found that the need for not using additional drills is there. So in this case, I will take my 3x8 and let me call it MA, and let me insert my cavity maybe here. That's my MA. Okay, now I can see a problem. Let me get back here. I need 15 as a max drill diameter. Otherwise, it's not allowing me to make the drill. Yes, let me do again. Let me place here so it will be, I have a better spot here. So the orifice command was not working inside a cavity made this way. So a cavity without the step 12. The need for having no step 12 is interesting because if you have a fixed geometry that cannot change the drill, that is the best way in order to create a feature that is difficult to edit except for the step 0. So which is maybe sinking a bit the cavity. Sometimes you want to add the orifice plug inside here, and now MDTools is supporting it. So we can use the orifice command, selecting the cavity. Maybe I need a M8. I want to merge with a cavity and click OK. And this will create a cavity with the orifice inside. And in earlier version, this was really not working. So there were workaround needed for the user. To be honest, and this comes with experience with usage, I have in my library usually already defined the cavities with orifice, because it's such a common situation where you want to add an orifice below a cavity, mainly in case of test point, where it's, for me, it's handier to have directly the geometry in the library. But as most of the attendees are aware, the library manager is very flexible. It's easy to create cavities, and we can manage them quite efficiently. So I'm sorry I went a bit longer than planned, but I think it was good to show you an entire workflow. So I turn it over to John, and thank you for the questions and for attending the webinar.
All right, thank you, Carlo. Yeah, so that we ran a little bit over. That was very compelling, though. So that's all the time we have for today to address questions. However, I think we answered some of the questions online, but if you had a question that pops up, please feel free to email us at support@bestusa.com with details. And again, I'd like to thank Carlo for delivering today's product webinar. We'll be grateful if you could complete a short survey at the conclusion of today's webinar. Tomorrow you'll receive an email containing details on how to participate in the MDTools 985 beta program, as well as a link to view a replay of today's session. So feel free to share this link with your colleagues as well. And then a link to view prior video segments of webinars will also be provided in that email as well. So you'll see on the screen here that we have our webinar series posted on various social media channels, and also on our website. We invite you to follow these channels and see that you can get the latest updates on upcoming webinars as well as product releases. That wraps up our winter 2025 webinar series. So stay tuned for announcements with details on the upcoming webinar series, our spring webinar series. So also want to remind you to take advantage of our survey to share any ideas for future webinar topics. So again, thank you, Carlo, and thank you all for your patience in attending today's session. Have a pleasant and safe day.